Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Further Mathematics Paper 2, which is a Further Pure Mathematics 2 for October-November 2023, and the code is 9231/22. So let's move on to question number 1. For question number 1, find the Maclaurin series for ln of x plus 2 plus ln of x squared plus 5 up to and including the term in x squared. Okay, just for information, Maclaurin series for fx, it is if it's f0 plus f prime 0 times x plus f double prime 0 over 2 factorial times x squared plus the infinity terms. Okay, so from here, I will write fx equals to ln of x plus 2 plus ln of x squared plus 5. So first of all, find f0. f0 will be ln of 2 plus ln of 5. Now, simplify this using ln a plus ln b, that is ln a times b. Then I will be getting ln 2 times 5, which is ln 10. Okay, so now f prime x. So to differentiate ln, fx, basically the formula is over fx and the numerator is f prime x. So here I will be getting equals to over x plus 2, differentiate x plus 2 is 1, plus over x squared plus 5, differentiate x squared plus 5, that is 2x. Okay, then from here my f prime 0, it will be 1 over 2 because x is 0, then plus, since the x is 0, numerator is already 0, therefore I'm getting half. Okay, so before I proceed to the differentiation, the next differentiation, I will move up the denominator for the first term first. It will be x plus 2 degree of minus 1, then plus 2x over x squared plus 5. Now, for my second derivative, I'm going to use another formula, differentiate fx degree n. That is n fx degree n minus 1 times f prime x. So which means now here, you bring down the minus 1, rewrite the whole bracket, degree becomes minus 2, and differentiate x plus 2 is 1. So for the second term, that is the quotient rule. Okay, so quotient rule is basically d over dx u over v, that is over v squared vu prime minus uv prime. So now here I will just write down my u and v. So that means my u is going to be 2x, so my u prime is 2, then my v, okay, here u, here v, right? So my v is x squared plus 5, then my v prime is 2x. So then from here, using the formula, I will be getting over v squared. So that means it's x squared plus 5 squared. Now keep the x, differentiate 2x is 2 minus uv prime. So that is 2x, and then the v prime is 2x. Then from here, right, you can just simplify. This is going to be negative 1 over x plus 2 degree 2. And then for the other term, basically, when you do expansion, this is 2x squared plus 10. But here is 4x squared. So 2x squared minus 4x squared is basically minus 2x squared. So I will write minus 2x squared plus 10 over x squared plus 5 squared. Then now I will just replace my x by 0. So that is going to be negative 1 over 2 squared plus 10 over 5 squared. This is minus 1 over 4 plus 10 over 25. At last, you will be getting 3 over 20. And then now I will just write down my Maclaurin series. Okay, substitute all the values into this formula. So I will write ln of x plus 2 plus ln of x squared plus 5 is basically the first term. Okay, refer to here, ln 10, then the second term is half times the x. Then lastly, this value times x squared over 2. So ln 10 plus half x plus 3 over 20 x squared over 2 factorial. Then now I will simplify this into ln 10 plus half x plus 3 over 40 x squared. So that is my Maclaurin series. Okay, so done for the first question. Now, question number 2 is given that x equals to 1 plus 1 over t and y equals to t exponential t. Show dy dx. So now, x equals to 1 plus 1 over t. I can change this to 1 plus t power negative 1. Then my dx dt, alright? So when you differentiate x degree n, you bring down the n, rewrite x, then degree minus 1. So degree because n minus 1. That means here I will be getting minus t power negative 2. And this can be simplified into negative 1 over t squared. Now, my y equals to TET. So this is product rule. So my product rule, d over dx uv, that is uv prime plus v u prime. Okay, so here I will write my u equals to t. So u prime is 1. My v is et. My v prime is also et. So it means that my dy over dt is basically T et uv prime plus et times 1. So from here, the exponential t is in common. So I can factorize out. And now, to get my dy dx, this is basically dy over dt times dt over dx. That is going to be exponential t times t plus 1 multiply. Okay, so I use the dot. dt dx. So for your information, dt dx is same as 1 over dx over dt. That means now I need to take inverse of this. Okay, 1 over that. So it will be 1 over negative 1 over t squared. That means et exponential t times t plus 1, 1 divided by negative 1 over t squared is basically negative t squared. And now you need to show this. Right, keep the exponential t, negative exponential t outside. So I'll get negative exponential t outside. So once you factorize a negative, right, and combine with this t squared must bring inside into the bracket. So it will be t squared times t, you get t cubed. Then t squared times 1, t squared. So with this, we have shown the dy dx. Now part B, find the d squared y over dx squared in terms of t. So I have to differentiate my dy dx. Okay, look at here. I'll copy back first. Dy dx is negative et t cubed plus t squared. So now I differentiate my dy over dx with respect to t. So now again, to differentiate this, since this is products of two terms, I will apply the products rule. So I will let u equals to negative e t. So now my u prime is negative et as well. Then my v is t cubed plus t squared. So my v prime is 3t squared plus 2t. And again, using products rule. So d over dx uv. That is uv prime plus vu prime. So now from here, I will be getting negative et 3t squared plus 2t plus t cubed plus t squared multiplied with negative et. So from here, the common term is negative et. So I will factorize this and combine the rest. So negative et, it will be 3t squared plus 2t, then plus t cubed plus t squared. So from here, you will be getting negative exponential t. Rearrange first. First term is t cubed. And then now here, I get 3t squared plus 1t squared. That is 4t squared. Followed by 2t. Okay. And now to get the second derivative. So second derivative of y with respect to x. That is, differentiate the dy dx with respect to t. Then now when you check the left and right side, the right side extra is dt, so I have to times dt, but I need dx, so times dx, dt over dx. So that means this is going to be negative exponential t times cubic function, and then my dt dx, you get it from previous part. So basically, look at here, dt dx end up with this. So I will just copy negative t squared. So here it will be negative t squared. Okay, and then now from here, I notice that the minus and minus is a plus, right? So here I will get exponential t, take out the t squared, and for the whole bracket, you can factorize t. T is in common. Therefore, take out the t, then you get t squared plus 4t plus 2. And now the t squared and t cubed, t squared and t can be combined to be t cubed. So my simplest form is t cubed times exponential t together with the quadratic function. So this is my second derivative. Okay, so for question number 3, use the Moivre's theorem to show this expression cos 5 theta equals to all the terms in, cos 5 theta in terms of cos theta. So we know that cos 5 theta plus I sine 5 theta, according to the Moivre's theorem, this is same as cos theta plus I sine theta degree 5. So I can write this as C plus IS degree 5. Okay, and now here you can just use the binomial expansion. So this is going to be C5 plus 5C1 C4 IS degree 1 plus 5C2 C cube IS squared plus 5C3 C squared IS cube plus 5C4 C IS degree 4, lastly IS degree 5. Okay, that is the binomial expansion formula, which is a plus b degree n, that is an plus nc1 an minus 1 b1 plus until bn. Okay, so now do expansion. So here is going to be c5, 5c1 is 5, so 5c4 is, so I write isi, right? Then 5c2, this is combination, this is same as nc1, right? So 5c2 is 10, then I get c cube s squared I squared, then plus 5c3 is also 10, then I get c squared s cube I cube, then 5c4 is 5, c s4 I4, then s5 I5. Okay, now simplify. I square is minus 1. I cube is I square times I. That means it's minus 1 times I. You get minus I. I degree 4 is square of I squared. That is minus 1 squared. Then you get 1. I degree 5 is I4 times I. That is 1 times I. Then you get I. Okay, so substitute all these results into your expansion. So then I will be getting, this is basically C5 plus 5C4 as I. Now remember, this is minus 1. Okay, this is minus I. I degree 4 is 1. I degree 5 is I. So now here I will be getting minus 10 C cube S square minus 10 C square S cube I plus 5C S4 plus S degree 5 I. Then from here, I will group the real and imaginary parts. So the real part is basically those without the I. Okay, the underlined one will be the real parts. So I will write C5 minus 10 C cube S square plus 5C S4. This is my real part. Then my imaginary parts will be the rest of the terms. and I factorize the I first, I will get 5c4 as minus 10c squared s cubed plus s degree 5. Okay, so now look at the question. We need to prove cos 5 theta. So cos 5 theta is basically real parts in this complex number. Okay, real parts of that complex number. So I will write here cos 5 theta is real part of cos 5 theta plus I sine 5 theta. That means I will just choose this because that is my real part. So therefore, I will be getting c5 minus 10c cubed s squared plus 5c s4. And now I change back. Okay, here I should write c is cos theta. Then the s is sine theta. So here I will get cos degree 5 theta minus 10 cos cube theta sine squared theta plus 5 cos theta times sine degree 4 theta. But then when you look at the question, here just in terms of cos, okay, cos theta, there's no sine. Therefore, I need to simplify this. So that means, okay, now here I need more space. So I will just continue at the back, right? So I will copy all this and continue here. Right, so this is a question 3a. So I will rewrite my cos 5 theta is basically just now was cos degree 5 theta minus 10 cos cube theta sine squared, then plus 5 cos theta sine degree 4. And now I need to change everything to cos theta. Okay, so now to change the sine squared to cos, I will have to refer to cos squared A plus sine squared A is 1. So then sine squared A is basically 1 minus cos squared A. So that means this is going to be 1 minus cos squared theta plus 5 cos theta. Then the sine degree 4 theta is basically square of sine squared. So the sine squared itself I change to 1 minus cos squared first. Then another square outside. That means now here I will just do expansion. So here this is 10 cos cube multiplied with 1 multiplied with negative cos squared theta. So you get negative 10 cos cube theta minus minus is a plus. So plus 10 cos degree 5 theta. And plus remain the 5 cos theta here and do the expansion for the 1 minus cos squared theta. Use this formula, quadratic expansion. Then you will be getting 1 minus 2 cos squared theta plus cos degree 4 theta. Okay, then now here I will just rewrite. Now look at here. The first and third term can be added. Therefore, I will get 11 cos degree 5 theta and then minus 10 cos cube theta and then followed by this 5 cos theta times into the bracket. So you will be getting plus 5 cos theta minus 10 cos cube theta plus 5 cos degree 5 theta. So now combine the first and last term. Those mean both terms with degree 5. So I get 16 cos degree 5 theta. And then for the cos, for the squared, for the cube, combine these two terms, it will be negative 20 cos cube theta followed by 5 cos theta. Okay, so now you check 16 cos degree 5 minus 20 cos cube plus 5 cos theta. Let's go back to the question. Exactly the same. Okay, so we have shown that form. So here I will just write shown. Okay, so this is the second part of the 3A. Now let's move on to the 3B. Okay, 3b, hence. Hence means use the previous result, obtain the roots of this equation. So 32x degree 5. Now you check. Just now was 16. Okay, 25. Then now becomes 32, 40, and 10. So it's just a double of the previous, right? So from here, I will just write, I will copy back first. Cos 5 theta equals to 16 cos degree 5 theta minus 20 cos cube theta plus 5 cos theta. So now I times 2 because the coefficients is double. So 32 cos degree 5 minus 40 cos cube theta plus 10 cos theta. Okay, so now from here, I will say that I minus, because right now I'm getting the same coefficients, but I have extra minus square root 2. So I minus square root 2 both sides. Okay, then from here, I would just say x equals to cos theta. Therefore, 3 cos 5 theta minus square root 2 equals to 0 for this equation. So that means now I will just solve this quadratic equation. I will just solve this equation, which means cos 5 theta is square root 2 over 3. Wait. Oh, sorry. This is 2. I wrote wrongly. This is 2. Okay. Then your 5 theta. Now look at here. Your cos is positive. Therefore, by reusing the quadrant, it will be between first and it will be in the first quadrant. Alright, so when you use calculator to get a basic angle, that is basically pi over 4. Inverse cos of root 2 over 2 is pi over 4. But now, you look at here, this is 5 theta, means that we need to generate 5 angles. Therefore, we have to plus 2 k pi. Okay, so my k basically will be 5 values starting from 0. So means that it will be from 0 to 4. So means now my theta is pi over 20 plus 2 over 5k pi. And now I know that my equation, okay, my equation in terms of x, the roots is x, and at the same time, my x is cos theta. So now I need to find out what is my theta, then I can find my roots. And you need to get your x in terms of, or in the form of cos q pi, where the q is rational number. So now from here, I will just calculate when k equals to 0. Right, my x will be cos, replace a k by 0, that is pi over 20. That's my first x. So when my k equals to 1, my x equals to cos of pi over 20 plus 2 over 5 pi. So this is cos of 9 over 20 pi. So when k equals to 2, x is cos pi over 20. Replace this k by 2, so 2 over 5 times 2 pi. That will be 4 over 5 pi. And then this is going to be cos 17 over 20 pi. So when k equals to 3, your x is cos pi over 20 plus 6 over 5 pi. That is cos 5 over 4 pi. Okay, last k value to get the last x. Then here you will get cos 33 over 20 pi. So done for this question. Now next question, number 4. Find the solution of the differential equation dy over dx plus 3y equals to sine x, where x equals to 0 when the y equals to 1, and give your answer in the form of y equals to fx. So now dy over dx plus 3y equals to sine x. So now you compare with the general form dy over dx plus ypx equals to qx. Then the I integrating factor is e integrate px dx. right? So means that my p here is basically plus 3. Okay, so my integrating factor I is e integrate 3 dx. This is e 3x. I let this be second equation. Now I times second into first equation. So supposedly there are two terms on the left side, but if you are confirmed that your I is correct, means that you will be getting the default result, which is d over dx yi. Okay, for the left hand side. Right hand side, it will be ex sine x. And now my ye3x is integration of ex sine x with respect to x. Now, for your information, this integration must be done using by parts, integration by parts. So integration by parts formula is integrate u v prime or u dv dx. I will prefer using that form. So u dv dx dx, that is uv minus integrate v du over dx. Okay, so now I will let u be trigonometric. Okay, then my my v prime, probably I just write it here, my u equals to sine x, my u prime is cos x, then my dv dx is exponential function, then my v is exponential function. Okay, so here you will just write, oh okay, here probably I write du dx. Now I will solve the integration first. That is uv, so ex sine x minus integrate v du, so ex cos x dx. Now again, ex cos x, just now was ex sine x. So now repeat the integration by parts one more time. So u equals to cos x, du over dx, integrate cos is minus sine. Okay, then dv dx remains as ex. Your v is ex because you integrate exponential function, you get back the exponential function. So now I will rewrite my question, my integration, that is ex sine x minus, okay, so for this integration, again by parts, alright? So by parts says that is uv, so ex cos x minus integrate v du, so ex minus sine x. And then now here, since there is a minus, so I will bring in this minus. Alright, then here I will be getting ex sine x minus ex cos x. So when you consider all this minus, minus times minus is a plus, then times another minus is minus. So I will write minus integrate ex sine x dx. Now, when you look at here, this is ex sine x, here is minus ex sine x. Means that now we have to move this integration to the left side. Okay, so minus minus, actually the integration of ex sine x, when you move this minus to the other side, becomes plus. So I will get 2 times of the whole integration after you plus. That is ex, and from the right side, I can factorize the ex because the ex is in common now. Okay, then from here, when you look at our question is integrate ex sine x. But now I'm getting 2 of the integration. Therefore, the 2 must be moved to the other side. But remember, this integration without limits, supposedly you plus k, okay, or plus c, or plus any other constant, arbitrary constant. So now my integration here equals to half of ex, because I divide by 2. So it will be sine x minus cos x plus k over 2. So this k over 2 I can change to c. Where c equals to k over 2. because the C is arbitrary constant, K also arbitrary constant. So now I will substitute this result, okay, this result into my working over here. Okay, so I will rewrite ye3x is the integration. So then I will write ye3x equals to half ex times sine x minus cos x plus c. But when you refer back to the question, your question is y equals to fx. Okay, your final answer must be y equals to fx and not ye3x. So now I move the e3x to the other side, which means you are, okay, wait. Oh, okay, here I made a mistake. This is e3x. Right, here is e3x. So where times this should be e3x. I miss out the 3 for all the question, all the terms. So here should be e3x. So here e3x. Here 3x. So this is 3x over 3. Okay, then here is going to be 3x. Here is 3x over 3. Right, so here I will write e3x over 3. Therefore, this is going to be 1 over 9 e3x. So here 3x uv. Okay, here I have to redo this part. So this is uv. So 1 over 9 e3x cos x. Then minus v du. So 1 over 9 e3x uv minus v du dx. So sine x. Okay, then here this one is, okay, 3x 1 over 9 e3x. Then here, okay, when you look at here, minus. Oh, okay, let me check. This is the second time. So minus is a plus. Now this term, okay, multiply with this is supposed to be a negative. I miss out the negative. Alright, so then when you look at here, minus is a minus. And then my coefficients, I have to change to 1 over 9. And this is e3x, it's not ex. Sorry about that. Okay, 1 over 9. Then when I move this negative 1 over 9 to the other side, it's like 1 plus 1 over 9. This one will be 10 over 9. This is 3x. So here is wrong. Okay. And then here is going to be over 9. This one is wrong. So this is uv. Okay, uv. Alright. uv, this is over 3. So here is going to be, right, let me write again. So here, when I move there, it becomes 10 over 9, integrate e3x sine x dx. So, okay, this term already moved to this side. So here, right side, I will get e3x over 3 sine x minus 1 over 9 e3x cos x. Then here, this is going to be integrate e through x sine x dx. So this is 10 over 9. Now for the right side, because you have two terms here, I can factorize 1 over 9 e3x. So once you factorize 1 over 9 e3x, that is 3 sine x minus cos x. Right? Then now integrate e3x sine x dx. So since both sides you have over 9, the over 9 can be cancelled off. The 10 move down. That is 1 over 10. So I will write here 1 over 10 e3x 3 sine x minus cos x. Okay, then here probably you can write k. Then for the k, you change to c plus c, whereby the c is basically k over 10. Okay, then now I will copy back all this result. So sorry for the mistakes. It is 1 over 10 e3x 3 sine x minus cos x, then plus c. Okay, and then now to get the y, I times e negative 3x. So this is y equals to 1 over 10. E3x times e negative 3x is basically 1. Therefore, 3 sine x minus cos x plus ce negative 3x. Okay, then from here, right? So then don't forget you are given the x and y values. So you can just leave it in this form first, or you can find the x and the c from the previous step, up to you. So now I will write when x equals to 0, y equals to 1. That means 1 equals to 1 over 10, 3 sine 0 minus cos 0 plus c is 0. Then from here, for your information, sine 0 is 0, cos 0 is 1. That means I will be getting 1 equals to 1 over 10 times minus 1 plus c. So my c is basically 1 plus 1 over 10, which is 11 over 10. Then my final answer, just substitute back this into your solution. That is 1 over 10 bracket 3 sine x minus cos x plus 11 over 10 e negative 3x. So since both also over 10, right here, I can factorize the over 10. So that means this is going to be 1 over 10 bracket 3 sine x minus cos x plus 11 exponential negative 3x. So that is your solution. Okay, now next question, number 5. So the diagram shows part of the curve y equals to x hyperbolic secant square x. Square of hyperbolic secant x and its maximum point m. Show that at m, this equation, and verify this equation has a roots between 0.7 and 0.8. So since the m is the maximum point, which means the dy over dx must be 0. That is also a stationary point. So now I will write y equals to x secant square x. So again, this is product rule. My u, okay, my u is x, then my du dx, or my u prime, okay, probably I can just write my u prime is 1. My v is secant square x. This is same as square of hyperbolic secant x. So my v prime, okay, so here I have to write here because of not enough space. My v is square of hyperbolic square of hyperbolic secant x. So now my v prime, now when you differentiate, you are actually referring to the formula, the power rule. The formula is called power rule. Differentiate fx degree n. that is n fx degree n minus 1 times f prime x. This is the formula. That means now I will write 2 hyperbolic second x degree 1. Differentiate hyperbolic second x is basically negative sec x tangent x. Okay, so when you simplify, this is negative 2 hyperbolic second, square of hyperbolic second x times hyperbolic tangent x. That is my differentiation. So that means now my dy over dx. Use the products rule. D over dx uv, that is uv prime plus vu prime. That means I will be getting x times negative 2 sec square x tangent x plus 1 times second square x, hyperbolic second square x. Okay, then from here, the common term is this. Then I will just factorize it. It will be square of hyperbolic second x bracket minus 2 hyperbolic tangent x plus 1. Okay, the remaining term just write down. Then now, since m is a maximum point, that means dy dx equals to 0. So the product of two terms equals to 0. Okay, but we know that the square of hyperbolic second x is basically 1 over cos square x. Alright, the first term cannot be 0 because if you let the first term be 0, 1 over cos square x equals to 0, right? Then when you times to the right side, it's like 1 equals to 0. That means from here, I will just write the hyperbolic second square x cannot be 0. Therefore, the second bracket must be 0. So when it is 0 compared with the given answer, I need positive 2 hyperbolic tangent x minus 1. So it means that now I will just move all the terms to the other side. Okay, I miss out the x. You see here, I still have x, right? So here should have x. So shown, right? And then now you need to verify that this equation has a root between 0.7 and 0.8. So this is done using the side change rule. So I will let the equation be fx. So now I calculate, or I replace the x by 0.7. Then I calculate f 0.8. Now when you calculate, make sure you change the mode of your calculator to radians. This is in radians. Okay, then from here, you will be getting the first value as negative 0.154, which is less than 0, and the second value is 0.0625, which is greater than 0. So you just write since f 0.7 less than 0 and f 0.8 is greater than 0, that is a sign change. So according to the sign change rule, there will be a root between 0.7 and 0.8. Okay, so this is how we verify the root between two values. Right, so done for this part. Now B, by considering a suitable set of rectangles, use the diagram to show this inequality. Okay, now look at the function first. Your function is basically x square of hyperbolic secant square x. So when you compare to this is basically x hyperbolic square x. Alright, so the summation means sum, the sigma means sum. So you replace the x by r start from 2 until n. That means your x start from 2 until n, right? Which means now it's mentioned that this m is between 0.8 and 0.7. That means probably here is 0.7 and then this is 0.8. Okay, and now the question says by considering the sets of a suitable set of rectangles. So which means this will be because this is the y value. Okay, this is the y value. So summation of the y value and relate it to the rectangles. So which means, okay, let's say here 1, this is 2, this is 3, this is 4, 5 until here is n. Okay, now you need to show that this basically this part is the y value. So I will say that this is summation of y value, but when we need to link it to the graph and show this less than this 4 terms, so it's basically I'm referring to the area. So this r squared of hyperbolic secant r is same as summation y times 1. Okay, whereby my 1 is the width of the rectangles. Okay, then my y is the height of the rectangles. But then I know that my first height is basically 2 hyperbolic secant squared 2. Okay, that is my first height, right? So now what I need to do here is look at these rectangles, right? All these rectangles to get less than the other one if it is area under the curve. So I have to draw rectangle. All these will be my rectangles. Right? So this is n minus 2 over n. So now when I refer to these rectangles, okay, so for the first rectangle, you see all this width will be 1. So my area of the rectangles is basically height times base. Base is 1. So the height, look at here. The first rectangle is basically referring to the x equals to 2. And this graph, the function is y equals to x square of hyperbolic secant x. Alright, that means I would say that when I refer to this line, this height is basically when x equals to 2 because I'm referring to the 2. So that is 2 hyperbolic secant squared 2. Right? And then for the next rectangle, okay, next rectangle, which is here, this height is referring to x equals to 3. So I'm referring to the second ordinate of each of the bar. That means this is 3 secant squared 3. Okay, so from here I will say that the area, sum of the areas of rectangles equals to 2 secant squared 2 times 1 plus 3 secant squared 3 times 1, okay, plus until the last one is following the n. That means this height is basically n secant squared n. Right? So now here I will write plus n second squared n. This is the height, and the base is 1. So basically, all this will be summation r second squared r from 2 until n. The 1 can be ignored. Okay, that's why I'm getting this left hand side. That is the sum of the areas of rectangles. Right? So with base with width 1 and height x second square x. Okay, then now here I will compare because it's given less, right? Here is less. So when it is less, that means now look at the graph. Basically, the total area of the rectangles is less than the area of the graph. Okay, because the area of the graph is basically all this from here onwards. So this will be the extra, right? All this will be the extra part. Therefore, my area under the curve is basically counted from 1 until n. Okay, here onwards. So now my area under the curve. Uh, 1 to n y dx, right? So that is equals to integrate 1 to n x second square x dx. So I would say that summation r from 2 to n r second square r is basically less than that integration. Alright? So now to show these 4 terms, okay, these 4 terms, I have to get it from or by solving this integration. So now I will just solve the integration first. So when I need to integrate this, right, I have to apply integration by parts. Okay, so I let u equals to x. Probably I just show it here. Integration by parts. Integrate u dv over dx. That is uv minus integrate v du over dx. So then from here, I will just write my u is x, and then my dv dx is hyperbolic second square x. Okay, then here my du dx is 1. My v, when you integrate this hyperbolic second square x, that is basically hyperbolic tangent x. So now substitute into this formula. This is going to be uv, so x tangent x with limits 1 to n. Now if you have limits, okay, so here add on limits. Then now here I will be getting minus integrate v du. So 1 to n hyperbolic tangent x dx. So now replace the x by n first. It will be n hyperbolic tangent n minus, when the x is replaced by 1, so I get 1 hyperbolic tangent 1 minus hyperbolic tangent integration of hyperbolic tangent x. This is hyperbolic sine x over hyperbolic cos x. Alright, so Then now, for the integration, we have this formula. Integrate f prime x over fx dx. This is basically ln fx plus c. So now we know that we integrate cos, that is sine. So from here, I will get n hyperbolic tangent n minus hyperbolic tangent 1. Then this integration is basically minus ln cos x. Then limits 1 to n. Okay, now when I replace the values, the limits, I will get minus ln cos n minus, so minus minus, okay, probably I show step by step. This is cos 1. Then here I'll get n tangent n minus hyperbolic tangent 1 then minus ln cos n plus ln cos 1. Okay, now check the answer. I have n tangent n, okay, which is here. And then I have minus tangent 1, okay, done. But then I need plus ln hyperbolic second n and minus ln hyperbolic second x, second 1. But right now I'm getting cos, okay, cos. So what I need to do here is, we know that second x is 1 over cos x, right? So now I have the cos. So I have a formula, ln a power b is b ln a, right? So that means now I'm here, I need to change to this form. So it means that the minus I will move up, so that 1 over cos will be second. Then this is also same as cos x degree minus 1. I need to get the power minus 1 first. Therefore here I will write this is n hyperbolic tangent n minus hyperbolic tangent 1 plus this minus I move up. That is ln cos n power negative 1. Okay, because we need to get cos. So here, right? Then now I will get, or probably I do step by step, I will write like that. So I will write like this, plus negative ln cos n, and then this plus I change to minus because I want minus to get the second, hyperbolic second. So here we write first two terms plus this is ln cos n degree minus 1 according to this formula. Then minus ln cos 1 degree minus 1. Okay, and then apply this. Ln cos power negative 1 is 1 over cos. Then here I will write minus ln 1 over cos 1. Then now n hyperbolic tangent n minus hyperbolic tangent 1 plus ln, okay, 1 over cos n, that is hyperbolic second n, minus ln 1 over cos 1, that is hyperbolic second 1. So now to get that form, okay, so just rearrange, the n comes first. So I will say, right, this is basically n tangent n plus ln second n, and then you have tangent 1 and minus ln second 1. Okay, so at last, because we know that the area, the total area of the rectangles less than the integration. Okay, therefore, you just write here summation r second squared r from 2 to n is less than all these 4 terms. So, shown. Okay, so done for this question. Right? Okay, now for question number 6. Given the P, state the eigenvalues of matrix P. So the eigenvalues is basically the diagonals, right? So it will be lambda equals to 1, 2, minus 1. Now use the characteristic equation of P to find P inverse. Okay, so now we need to get determinant of P minus lambda I equals to 0 first. Then basically you are getting 1, 0, 0, minus 1, 2, 0, 1, 1, minus 1, all this, minus lambda times I. I is the identity matrix. Then now here, basically you are getting 1 minus lambda. Just a diagonal, you minus lambda. The rest remain. Okay, then from here, to get the determinant, I fix the first column and label the sign. I choose this because in that column there are 2 zeros. So I will just need to calculate the first row. So the cross out is 1 minus lambda. Then the remaining will be 2 minus lambda, 0, 1 negative minus lambda equals to 0. Now this is 2 by 2 determinant. So the green arrow minus the orange arrow. Okay, then you will be getting 1 minus lambda, 2 minus lambda times minus 1 minus lambda, minus 1 times 0 is 0. That means now 1 minus lambda. Now here I will just do multiplication. Okay, multiply first. So that is going to be minus 2 lambda plus lambda squared. Then now here, when you simplify, the 4 terms becomes lambda squared minus lambda minus 2. Okay, and now to get the characteristic equation, we need to get the cubic equation from here. So do expansion again. Means that 1 multiplied to whole bracket followed by minus lambda multiplied to whole bracket. Then here you will be getting lambda square minus lambda minus 2. When minus lambda times to the whole bracket, you will be getting minus lambda cube plus lambda square plus 2 lambda equals to 0. Okay, then I simplify. There's only one term with lambda cube. Then for the lambda squared, you have lambda squared and plus lambda squared. Therefore, 2 lambda squared. Positive. And then followed by the terms with lambda. So minus lambda plus 2 lambda is plus 1 lambda. Then lastly, minus 2 equals to 0. Okay, then times the whole equation by minus. So you are getting lambda cube minus 2 lambda square minus lambda plus 2 equals to 0. And now we are interested to use the characteristic equation of P to find P inverse. So what you do is you change your lambda into P. Okay, so now P cube minus 2P squared minus P, but you cannot just write 2 because 2 is a constant. Now you are getting all the matrices. So it will be 2i. I is the identity matrix. And use this characteristic equation to get the P inverse. So the easiest way to get P inverse is I times P inverse to this whole equation. So which means P cubed minus 2P squared minus P plus 2I. I multiply with P inverse. That equals to 0 matrix times P inverse. So P cubed times P inverse. This P inverse times into the whole bracket. It will be P squared. Then minus 2P minus P times P inverse is basically I, identity matrix, plus 2. I P inverse is P inverse. Then right side is 0. Okay, then from here, my 2P inverse, so the rest of the matrices will be moved to the right side. So then I will be getting minus P squared plus 2P plus I. Hence, my P inverse is half of all of this. But now, to get the P inverse, I need to know what is my P squared. Okay, so now I need to calculate my P squared first. So, okay, I will calculate my P squared over here. Okay, so I will write P squared. P squared, you just multiply this 2 times, right? Multiply itself. So I will get 100 minus 120, 1 minus 1. So for the multiplication, right, just show you this, row times column. So 1 times 1, I get 1. Okay, then row times second column. So number times number plus another number, then plus another multiplication. So that means here you will be getting minus 1 minus 2. Okay, then the next one is 1 minus 1 minus 1. Then now for the second row, continue with second row and first column. Second row in the first bracket, in the first matrix. So you get 0. Then the next one is 2 times 2. So it's 4. Then the second row and third column, you will be getting 2 minus 1. Okay. Then the last row, okay, so continue here, last row and first column. So just multiply. That will be 0, 0, and 1. So then from here, I will simplify it into 100 minus 340, then minus 111. That is my P squared. And now I need to calculate minus P squared plus 2P plus I. So minus P squared plus 2P plus I, that is going to be times minus to this whole matrix, plus 2P, so times 2 to this matrix, right? So I will be getting 200 minus 240, 2 minus 2. And then the I is identity matrix, 100, 0, 0, 10, 0, 1. Then now here, when you add up, okay, so I will get 213, 011, 00, negative 2. That is my minus P squared plus 2P plus I. But then now my P inverse is half of the whole matrix. Therefore, I'm getting 100, half, half, 0, 3 over 2, half, and minus 1. So this is my P inverse. Okay, now part C. The 3 times 3 matrix A has distinct non-zero eigenvalues A half 2 with the corresponding eigenvalue vectors. Find A inverse in terms of lowercase a. So given the eigenvalues, I can just write my matrix D as A0, 0, 0, half, 0, 0, 0, 2, corresponding to the matrix P. My P is consists of all the eigenvectors in this order, right? So it will be 1, 0, 0, negative 1, 2, 0, 1, 1, negative 1. So now, this is such that A equals to PD P inverse. But now you need to get A inverse. So when A equals to PD P inverse, okay, so then when I change my A into A inverse, that is PD P inverse P inverse. Okay, that is the formula, right? Because our formula is A degree n equals to PD P inverse degree n. And this is going to be PDN P inverse. That is the formula. And then now, to get the A inverse, I will rewrite my P. Now, for information, for the D, right, when you have any degree, just consider the degree of all the diagonals. Okay, so now the degree is -1. So I will just consider the degree of -1. Therefore, it is 1 over A, 0, 0, 0. 1 over half is 2. Then 0, 0, half. Multiply with P inverse. Okay, now you check. This is your P. Okay, this is your P. This P is basically same as the given P here. So we have found the P inverse just now. This is your P inverse. So I will just copy this P inverse. Okay, that means here you will be getting 1, 0, 0, half, half, 0, 3 over 2, half, and -1. Then now you just need to do expansion. Okay, so expand, multiply, and then followed by this column and this column. So here I will just give you the answer. This is 1 over A, 0, 0, 1 over 2A, 1, 0, 3 over 2A, 1, negative half. Okay, and then you multiply again for these two matrices. You will be getting 1 over A, 1 over 2A minus 1, 3 over 2A, minus 1 minus half. And then here 0, 2, 2 minus half, 0, 0, half. Then at last, okay, to simplify the answer, you will just get 1 over A, 0, 0, 1 minus 2A over 2A. Then 2, 0, and then 3 minus 3A over 2A. Then 3 over 2 followed by half. So this is your A inverse. Okay, done for this question. Let's move on to next question. Next question is question 7. A, starting from the definitions of cos and sine in terms of exponentials, prove this identity. So we know that cos A, because here is A, it will be half EA plus E minus A. Sine A is half EA minus E minus A. So I will start from the left hand side. That is 2 sine squared A. This 2 sine squared A is same as 2 sine A squared. So now I will write Sine A is half EA minus E minus A. Then you square it. Now this square you bring it into the half and also the bracket. So here I will get 2 of 1 over 4. And then for the expansion, quadratic expansion, A minus B squared, that is A squared minus 2AB plus B squared. That means you will be getting E to A. Now EA times E minus A is basically E0, which is 1. So I will get minus 2 plus E minus 2A. So then the 2 and 1 over 4 cancel off, becomes half. Then here you will be getting half E to A plus E minus 2A, and then the half times minus 2 is basically minus 1. Then I will be getting, now you check here. Here cos A, here will be A. Okay, together with the half. This is a half, but now my A has been changed to 2A. That means obviously this is cos 2A. So shown. Okay, now next part. A curve has equation y equals x squared, x from 0 to 2 over 3. The area of surface generated when the curve is rotated through 2 pi radians about the x-axis is denoted by s. Use the substitution x equals to half sine u to show s is this result. Okay, now the s, right, just for information, the s is basically integrates 2 pi y square root of 1 plus dy over dx, then square. This is the formula. That means now firstly we have to find out what is the dy dx. So then from here I will write y equals to x squared. So my dy dx is x degree 4. Oh, sorry, my dy dx is 2x. Okay, so now my s is integrate from 0 to 2 over 3, 2 pi y square root of 1 plus dy over dx squared. And now I replace the values. 2 pi y is x squared, square root of 1 plus 2x squared. Then this is going to be 2 pi factorize. Factorize the 2 pi because it is constant. X squared, square root of 1 plus 4x squared. And now, in the question is mentioned that you use substitution x equals to half sine u to solve that. Right, so from here I will write x equals to half sine u. Okay, or probably I just do it here because we need a lot of space. So x equals to half sine u. I need the dx. So it means dx over du equals to half cos u. And then I need to get the dx. So my dx is half cos u du. So with this, I have obtained this expression. Okay, and now I know that my x is half sine u, so I can find this. But what is this result? Okay, so okay, it's the same. Now I need to find out the limits now. So when the x equals to 0, means 0 equals to half sine u, then my sine u is 0. Therefore, my u is at sine 0. So at sine 0, you can get it from calculator. That is 0. Then the next value, x is 3 over 2. Means 3 over 2 is half sine u. So the 2, the half can be cancelled off from both sides. So now my sine u is 3. So my u is at sine. Okay, let me check. X is half sine u. Okay, wait. my limits, upper limits 2 over 3 is not 3 over 2. I wrote wrongly. 2 over 3. So 2 over 3, 2 over 3 half. That means now my sine u is 4 over 3. So here is wrong. Okay, and then when you refer to the answer in terms of ln and fraction, there's no sign. That means now I need to refer to my expression. So for your information, inverse sine x is ln x plus square root of x squared plus 1. Okay, that means now my u is inverse sine 4 over 3. That is ln of 4 over 3 plus square root of 4 over 3 squared plus 1. So then when you simplify this, this is going to be ln 4 over 3 plus 5 over 3. Okay, at last this is ln 3. That means when x equals to 2 over 3, my u is ln 3. So now I will change all. So now my s is 2 pi integrate. Okay, so limits 0 to 2 over 3. So when x equals to 0, look at here, x 0, your u is 0. Alright, when x is 2 over 3, your u is ln 3. So now my new limits will be 0 to ln 3. So here I will write 0 to ln 3. Then x squared, so square of half sine u. Square root 1 plus 4x squared. So 4x squared, basically, you can get it from here. You see, x is half sine u. That means 2x is sine u. So 4x squared means you square both sides. That is sine squared u. So here I will change to sine squared u. Okay, then my dx already found, which is here, half cos u du. So here I will write half cos u du. Okay, then this can be simplified. 2 and half cancel. Right, wait. Oh, x squared. Okay, I forgot to square. This is actually squared. Alright, so you cannot cancel. So now when I bring in the squared, this half becomes 1 over 4. So I will write 2 pi bracket 1 over 4 integrate 0 to ln 3 sine squared u square root 1 plus sine squared u then half cos u du. So the half and 2 will be cancelled off. Okay, then I will be getting equals to 1 over 4 pi integrate 0 to ln 3. So the cos square, this is sine squared u. Now for your information, we have identity. Cos square a minus sine square a is 1. So this is 1 plus. So move this to the other side. Cos square a is 1 plus sine square a. Okay, that means here you will get square root of cos squared u, then another cos u du. Then here, when you simplify, Okay, then here you are getting 1 over 4 pi integrate 0 to ln 3. This is basically cos. Okay, so sine squared times cos squared. That is sine u cos u squared. Okay, then now use the formula 2 sine a cos a equals to sine 2a. So now this is sine a cos a. So means the 2 move down. That is half. So I will get 1 over 4 pi 0 to ln 3. This is half sine 2u squared. Then now here you will get 1 over 4 pi. The square you bring it in, it will be another 1 over 4 sine squared 2u du. Okay, now to integrate sine squared, again another formula. Cos 2a is 1 plus 2 sine squared a. So sine squared a equals to cos 2a minus 1. Hence, your sine squared a is half of cos 2a minus 1. Okay, so now here I will just replace this 1 over 4 taken out. So 1 over 16 pi integrates 0 to ln 3. Then 1 over 2. Now when you compare, your a is 2u. Okay, that means here 2a will be 4u. So I will get cos 4u minus 1. Then now the half taken out again, 1 over 32 pi. Then integrate cos 4u. You will get sine 4u over 4. Then the minus 1 becomes u. Limits 0 to ln 3. Then now here 1 over 32 pi 1 over 4 sine 4 ln 3 minus ln 3 minus, okay, when the u equals to 0, you will be getting 0 for all. And now I'm getting this result, but when you look at the given answer, there is no sign. Okay, so I'm getting fraction. So again, use the formula. Now here it will be 1 over 32 pi 1 over 4. Remember just now, the sine a is half of EA minus E minus A. So here it's going to be half of E 4 ln 3 minus E negative 4 ln 3. Then minus another ln 3. So here you will be getting, okay, 1 over 32 pi. The pi is not in the, it's not the denominator, it's the numerator. Then here is 1 over 8. This is E ln 3 power 4 minus E negative ln 3 power negative. Sorry. Okay, like this. Then minus ln 3. Now, we have a formula. E ln A is A. Therefore, this is 1 over 32 pi 1 over 8. This is 3 power 4 minus 3 power negative 4 means 1 over 3 power 4. Then minus ln 3. Okay, so now you just press your calculator. this is going to be 8. 1 over 8, 81 minus 1 over 81. Then you will be getting 1 over 32 pi. Then 820 over 81 minus ln 3. So we have shown the answer. Okay, now question number 8 is given v equals to u y degree 4 and the second order differential equation. Show the second order equation in terms of second order differential equation in terms of v and x. So now I'll copy the question first. Y cubed d square y over dx squared plus 3y squared dy over dx squared plus y cubed dy dx plus y4 equals to e negative 2x. Let this be first equation. Now my v equals to y degree 4. So when I need to get dv dx, basically you are differentiating the y degree 4 with respect to x. That is same as 4y cubed. You differentiate with respect to y first, then you times dy over dx. This is your dv over dx. Okay, so now from here, I can say my d square v over dx squared. This is a product rule. So your u is 4y cubed. Then the v is dy dx. So now I will keep the first, differentiate second, right, to get second derivative, plus keep the dy dx and differentiate 4y cubed. So differentiate 4y cubed with respect to x, 12y squared dy over dx. That is the chain rule. Then from here, I will get 4y cubed d square y over dx squared plus 12y squared bracket square of the dy dx. This is my second derivative. Okay, so now I will substitute all this into my first equation. So look at the first equation. Basically, first equation, I need this. So I have here, right? So therefore, never mind, I get my 4y cubed first. So it means that now here, I will get 4y cubed d square y over dx squared equals to d square v over dx squared minus 12y squared dy over dx squared. Then now my y cubed, it will be 1 over 4 of all of this. That means I will be getting 1 over 4 d squared v over dx squared minus 3y squared dy over dx squared. Okay, so now I will substitute into the first equation now. So from first term already found. That is the latest result, 1 over 4 d squared v over dx squared minus 3y squared dy over dx squared. I will keep this in terms of y and x first because I noticed that this can be simplified by the next term. So copy back. After that, plus y cubed dy dx. I need y cubed dy dx. Look at here. This is my y cubed dy dx. Okay, so which means here I should write my y cubed dy dx is basically 1 over 4 dv dx. So I will write down 1 over 4 dv over dx. That is my y cubed dy dx. Then plus y degree 4. Y degree 4 is basically my v. So plus v equals to e negative 2x. Then from here, the second and third term will be cancelled off. And now you are getting 1 over 4 d squared v plus 1 over 4 dv dx plus v equals to e negative 2x. Now I times the whole equation by 4. Therefore, d squared v over dx squared plus dv over dx plus 4v equals to 4e negative 2x. So now check with the given answer. It's exactly the same. So shown. Okay, now next part, B. Find y in terms of x, where x equals to 0, y equals to 1, dy dx equals to negative 3 over 8. So now I use the second order differential equation in terms of v and x to solve first. So firstly, let's right side be 0. Okay, give me 1 minute. So now from here, we will be getting the auxiliary equation, which is m squared plus m plus 4 equals to 0. Now this is a quadratic equation. Solve this using quadratic formula. Therefore, I will write down my coefficients for all the terms. So now since your equation in terms of m, you will be getting m, even though you use this formula. So that is square root of 1 minus 4 times 1 times 4 over 2 times 1. That means you are getting minus 1 plus minus square root of negative 15 over 2. Remember, square root minus 1 is I. Therefore, this is minus 1 over 2 plus minus square root 15 over 2i. Then now, since you are getting complex roots, my complementary function v equals to e negative half x a cos square root 15 over 2x plus b sine square root 15 over 2x. Okay, so with this, I found the CF complementary function. Now I get the particular integral. So I start with trial solution. My v equals to, look at the right side. The right side is 4e negative 2x. So copy back this, but then in terms of, in general form, I would say it will be in general form. Then make sure you don't have this same term, this term in the CF. So otherwise, you have to times x to your solution, to your trial solution. So now my dv dx, differentiate exponential function, just rewrite. Then you differentiate minus 2x is minus 2. And then now second derivative, still the same. So I rewrite all this. Differentiate minus 2x is minus 2. Combine with the minus 2 becomes 4. So I let all this be second equation. And this is the first equation. Now I substitute second into first. So my second derivative, 4pe negative 2x plus dv dx is negative 2pe negative 2x. Then plus 4v. So plus 4pe negative 2x equals to the right side. So for the left hand side, basically when you simplify, there is 4p minus here. 4p minus 2p plus 4p. That means it is 6p. So I will write 6p e2x, e minus 2x equals to 4e minus 2x. So when you compare, 6p is 4. Therefore, your p is 4 over 6, which is 2 over 3. And with this, you have found the particular integral, which is v equals to 2 over 3 e negative 2x. Okay, so now I combine the CF and the complementary function and particular integral. Therefore, I'm getting general solution. V equals to CF plus PI. That is e negative half x a cos square root 15 over 2x plus b sine square root 15 over 2x, then plus 2 over 3e negative 2x. Okay, now look at here. You are given x, y, and dy dx values. So now I will change back. Remember, your y is y degree 4. Okay, so from here I will write y degree 4 is all these results. Okay, so now replace the values because now our solution will be in terms of x and y. So x 0, y is 1. So when x equals to 0, y equals to 1, that means 1 degree 4 is E0, a cos 0 plus b sine 0, then plus 2 over 3 E0. Okay, now E0 cos 0 is 1. This is 1. Sine 0 is 0. E0 is 1. Okay, here is 1. That means now I'm getting 1 equals to a plus 2 over 3. Therefore, my a is 1 minus 2 over 3, which is 1 over 3. Okay, now for the next value, which is the dy dx. Look at here. You are given dy dx. So it means that I need to differentiate my y. Okay, so y degree 4, that will be 4y cubed dy over dx when you differentiate. Then now for the first term on the right side, so since I need a lot of space, I will write here. Again, to differentiate the right side, this is products rule. Okay, here is the v. The exponential is the u, the brackets is the v. So the formula is d over dx uv equals to uv prime plus vu prime. Therefore, you will be getting exponential, that is my u. Differentiate a cos, you will get minus square root 15 over 2 sine. A is missing. Sine square root 15 over 2x plus b sine, differentiate sine is cos. So bring out the square root 15 over 2. That is this result. Okay, then you rewrite the whole bracket. Then you differentiate exponential negative half x. So you rewrite the whole exponential function and differentiate negative half x is basically negative half. And then now for the last term, okay, so you differentiate negative 2x, that is negative 2. So negative 2 times the 2 over 3, that is negative 4 over 3. So I will direct write negative 4 over 3 exponential negative 2x. Okay, now here replace x by 0, y by 1, dy dx by minus 3 over 8. So where x equals to 0, y equals to 1, dy dx equals to minus 3 over 8. So now left hand side I'll get 4 times 1 cubed times minus 3 over 8. Then for the right hand side, you will get E0 because the x is 0 minus square root 15 over 2a sine 0 plus square root 15 over 2b cos 0, and then plus a cos 0 plus b sine 0 multiply with negative half e0, then last term 4 over 3 e0. Okay, remember e0 is 1, sine 0 is 0, cos 0 is 1. Okay, this is 1, this is 0, this is 1, here is 1. That means now I will be getting left hand side is basically 4 times negative 3 over 8. You are getting negative 3 over 2. Because the 4 and 8 can be simplified. For right hand side, the sine 0 is 0, so the a is missing. Then you are getting just square root 15 over 2b. And then plus a times by negative half. Then minus 4 over 3. Okay, so from here, I need to get the b. So I replace my a first. My a already found just now. My a is 1 over 3. Okay, so now I will write negative 3 over 2 equals to square root 15 over 2b plus 1 over 3 times negative half minus 4 over 3. So now, to get the b, just move all the terms to the other side. So I will write square root 15 over 2b is basically negative 3 over 2. This is negative 1 over 6. So when I move to the other side, it becomes plus 1 over 6. And same goes to the last term, negative 4 over 3. When I move to the other side, it becomes plus 4 over 3. So from here, when you just calculate the right hand side, it's basically 0. Okay, which means my b is 0. So once you get a b, my result, just substitute back into here to get the solution. So I will get y degree 4. So I continue this side. This is question 8. Right, I will get y degree 4 then equals to exponential negative half x. And then a cos, the a is 1 over 3, a cos, so 1 over 3 cos square root 15 over 2, the b is 0. So 1 over 3 cos square root 15 over 2x, close bracket, and the last term 2 over 3 e negative 2x. Okay, now check the question first. The question says find y in terms of x, means that I need to get y degree 1. Okay, and now I'm getting y degree 4. So from here, before I simplify, I notice that the first term I can rearrange first to get a nicer form. Okay, so if you want, you can factorize 1 over 3 as well. It's up to you. So at last, my y is, now when we need to get the y as the subject, this is y degree 4. So since the degree 4 is even power, when you eliminate the even power by moving it to the other side, it should be plus minus. So here plus minus. So all these terms with degree of negative, degree of 1 over 4. Okay, so this is your final answer for question 8. Alright, so I have completed the whole paper and also comes to the end of the video. Thanks for watching. If you enjoy watching my video, please like this video and subscribe to the channel. Okay, and also share this channel to your with your friends. Now to show support to this channel, you may click the thanks button below the video. Alright, thank you everyone and stay tuned for more upcoming videos. Bye.